Hello and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. Welcome, Stephen Lambert.
Thank you, Ryan. Great to be here.
If we could just start off with a bit of an introduction to yourself, Steve, where you've come from and how you got to where you are now.
Yeah, okay. So hi, I'm Stephen Lambert. I'm currently CTO at a company called Protean Electric. But I've been working in hybrid and electric vehicles for, I think, almost 20 years now, 19 years or so. I like to say I've been doing it since before it was cool.
Yeah, I use that one too.
Yeah. But in that respect, I think, when we started out at that time, there's probably less than 100 people, for example, in the UK who were working in hybrid and electric vehicles. It was a really small industry. And to be honest, I kind of fell into it. I left university and didn't really have any plans. I was actually living in a pub, running a pub, having great fun. And my supervisor from university called me up and said, "Do you fancy doing a PhD?" And I thought, well, that's probably a little bit more useful in life than having fun running a pub.
Less fun, though.
less fun. Well, it meant I could be a student for another 4 years in some respects. But it was really that, and sort of actually realizing, this hybrid stuff's kind of interesting.
Right.
Plays to my skill sets. I could do a bit of research into this and see where it goes, and kind of got into it in that way.
So you did engineering, an engineering degree to begin with. Where did you do that?
So I did my undergraduate at University of Warwick.
Okay.
I originally wanted to do computer science. One of those kids where we had a BBC Basic that I would take apart, or the 486, and try and do stuff with Windows 3.1 and all of that sort of stuff.
Yeah.
And wanted to do computing, and applied for computing at the University of Warwick. And then when I hit 17, I started driving, and I was like, oh, cars are quite cool as well, actually. I quite like messing around with old cars and trying to get them to work and everything else. So actually, when I got to the university, I ended up changing my course a bit and doing different subjects from mechanical engineering and automotive engineering, and having quite a wide overall subject matter to my degree. So quite a wide.
Oh, cool.
Yeah.
So you almost couldn't have been here. You might have been off locked in a cupboard somewhere coding.
I could have been earning far a lot more money in computers, I'm sure.
You'd look a bit paler, though.
Well, yeah, probably. Yeah, we'll see the sun a little bit less.
Yeah.
But cool. So I kind of fell into it. But I just as I started driving, I was like, you know what, I quite enjoy working on cars and understanding how they work, and it just spoke to me a bit more.
So you then did a PhD at Warwick again, presumably?
It was at Warwick, yeah. It was a PhD turned into an EngD, which is where you work with a company.
Okay, engineering doctorate.
Engineering doctorate, exactly.
Very popular in Germany.
Ah, okay, yeah. It's half in a company, half in the university. So it takes 4 years as opposed to 3.
Yeah.
But you work with a company doing a project, sort of research project, but the focus is on innovation. So you can do a PhD and you can add sort of new knowledge to the body of knowledge in that particular area. It doesn't have to be useful.
Yeah.
The difference with an EngD is it has to kind of be useful, and the company has to kind of be able to take it on and do something.
Yeah.
So it was sort of, practical is the wrong word, but it had to have an end goal in mind, an end application in mind. And ultimately, I got the chance. I worked with a company called Potenza, who were part of Westfield Sports Cars, and I got to mess around building sports cars for a couple of years as well. So we did a hybrid Westfield. There was an electric Westfield that I was sort of involved with. We did a diesel Formula 3 car with the university.
Yeah.
So I managed to touch on quite a few sort of interesting projects at the time.
Okay. I didn't know that you had started at Potenza, actually, so I've learned something already.
Yes, no. When I was at Potenza, there was, I think, 2 of us in an office working out a ProDrive at the time.
Right.
It was quite small, yeah.
Okay, yeah, very good. So then finished your Eng stock. What happens next?
Well, again, it was sort of, I got to the end of my end stock, and I was like, well, what do I want to do? Do I want to stay here in academia and pontificate and think about what the future could be,
Mm.
or do I want to get out there in the real world? And at that point, there wasn't huge amount of options for hybrid electric vehicles in the UK.
Yeah,
There were really only two main companies hiring at the time. One was McLaren Automotive, who at the time were developing the MP412C,
yeah,
and the other was Lotus Engineering, who were doing a load of consultancy work. So I applied for both, interviewed for both. McLaren didn't want to give me a job, so I ended up going to Lotus, and actually did some really interesting projects at Lotus, and
yeah.
loved it.
Okay, very good. And then and that was kind of in because at the time back then, Lotus had obviously a different business to what it is now, different ownership and so on. But they had quite a big sort of engineering development business where they were doing kind of advanced research and some prototype vehicles and demonstrators and stuff, and seen some. My old business was involved in some of those, providing hardware to go into some incredibly sexy, futuristic vehicles that were way ahead of their time.
Yeah, it was a great time. Certainly to be in Lotus Engineering at that time, there was a lot of other stuff going on in Lotus. I think Lotus goes in cycles in terms of who
Yeah,
its owners are, whether it's focusing on building new cars or just trying to sell them, and whether it's innovating. But Lotus Engineering was a little bit outside of that and was just
yeah,
focusing on the third party consultancy. So, um, the main project I was involved in when I got there was a project called Rolls-Royce 102EX, which
yeah,
was electric Rolls-Royce. Again, really ahead of its time. It was the biggest battery pack put into an automotive application at that
yeah.
point.
A
About,
very
I
big
think
battery pack.
it was a very big battery pack. It weighed a lot. It was in today's numbers, not that big. I think from memory, 70 something kilowatt hours.
Yeah,
So not massive, but it took up the entire boot area at the front of a Rolls Royce.
yeah,
But yeah, it was that was a really really good project. Had a lot of fun driving around the back roads of Norfolk in a electric Rolls Royce, tuning the throttle response and the systems and getting that to work.
yeah. Fantastic. Um, and then you then you sort of went on to something similar but quite different after you finished up
Yeah,
at Lotus.
so I did a few projects at Lotus, and again, all really interesting, futuristic projects. But I kind of got pigeonholed is the wrong word, but I ended up as kind of the battery guy. So at that point, batteries for automotive was a little bit of a cottage industry.
Yeah.
There was a few people in the UK doing it. There were no real standards to it.
No.
Nobody really knew what they were doing. There were people.
Hey, some people knew what they were
Well,
doing.
some people they were
Us
doing.
lot up in Newcastle knew what we were doing.
Well, yeah, no, I know.
Sort of.
Sort of, yeah. There was. There wasn't the supply chain of parts. There
No.
wasn't the So, for example, we knew we had to use orange cables, or some people knew how to use orange cables, but it wasn't that easy to buy them, and you ended up using sometimes welding cable, which happened
Yeah.
to be orange, but wasn't, or some people did. And so there was always this sort of, okay, how do we do this? Do the engineering to the best that we can
Yeah.
with what we have available in the volumes that we're trying to do.
Having to
or the
make your
one-offs that we're trying to
own
do.
leakage detection circuits and stuff. And,
Yeah, exactly,
yeah.
exactly.
Them's were the days.
They were exactly
Welding
yeah.
contactors. Yeah.
Yeah. So I kind of ended up as the battery guy at Lotus there, just sort of working with the suppliers and helping, helping to bring a Lotus view to how they should be building the batteries and doing that. And so an opportunity came up at a company called LifeBat, which was doing batteries in the UK. They were actually importing a lot of the cells and technology from Taiwan, and making sort of standard modules with a bit of a basic BMS, and then wanting to get more into kind of the automotive and what was happening in that market there. And I kind of thought, well, I should put my money where my mouth is. I spent the last couple of years telling battery suppliers how I thought it should be done. Maybe I should sit on the other side and try and build some some really exciting batteries. So that's what I did.
Okay. And LifeBat was a sort of startup type growing,
It
quite high
was,
growth
yeah. I'm
environment.
trying to remember the numbers now. It was probably, the engineering department there was 2 or 3 people, I think, when I joined. They'd just taken some investment on, managed to grow that up to. I can't remember the numbers. Double figures. Not a huge growth, but those days it was a decent sized team doing battery engineering, and we had some interesting projects, a couple of military projects. We had some automotive projects. And we're able to pull together some really quite interesting batteries. But because of the way in which they put the cells together, you could be quite flexible and actually prototype batteries quite quickly.
Yeah.
So that was a really good advantage, really interesting, but really nice, really good opportunity to say, you know what, this is how we should be building batteries and how we should be taking it forward and delivering, OEM quality, automotive quality batteries to the market.
So, because actually, like all of this, you've been through quite a lot there, and I think a lot of listeners would assume that this was then not that long ago, but that is still
that was still 2010, 2012, something like that. Yeah.
So still a while ago.
Still a little while ago. Yeah. No, exactly. And, I say, okay, yeah, we might have had an engineering team of 10 people. Trying to find that number of people who knew anything about batteries wasn't easy.
No.
Again, it was a very, very small industry back then.
Yeah, and we were right in the middle of that as well.
Yeah, no, absolutely. You guys were there. We were maybe not competing, but
no,
but adjacent, definitely.
Good friends with the LifeBat team and some of the guys there, but because that business then sort of changed and.
Yeah, so they had some financial struggles as most businesses do at some point, particularly in those days where the market's still quite green and you're trying to scale, but perhaps the market isn't quite there. And so while that was going on, the opportunity came up. I had a recruiter call me and said, "Do you want to come and work in Formula One?" McLaren Racing were looking for people to come and develop the battery pack for the Honda F1 engine that they were developing. Interestingly, actually, when I applied for the job, they wouldn't tell me what the job was because it was really, really secret. The Honda and McLaren, Honda were thinking about coming back into Formula One.
Right.
So the role was actually advertised by another company within the McLaren group. I went over there and they said, "Yeah, you're not actually applying for this job. We're going to walk you over to Formula One." And I sat down there with some other people to talk about what a Formula One battery could look like, unbeknownst to me.
Proper secret squirrel stuff.
Exactly.
The battery storage cars were launched into the 2014 season?
Yes, 2014. Yeah, 2014. So I joined there in 2013. Yeah, 2013, I think.
Right. Yeah.
And McLaren Honda were a year late, so they'd used the Mercedes engine, and then were a year late with the new regs.
Yeah.
And so it started 2015 was the first season my car with my battery system was running.
Right, with taking the power from the because they had MG UK and MG UH.
That was it. That was a change. Yeah, they went from they had both the motor on the wheels on the engine, then a motor on the turbo as well. So it was the two motors.
Yeah.
Which obviously they're getting rid of now. I think next year.
Yeah. Oh, interesting.
Yeah, I usually joke my claim to fame. I mean, working in Formula One was a great experience. My claim to fame was the car that had my battery system on was the worst performing car in McLaren's history.
Okay, that's a good claim. Yeah.
It was, but it was it sort of teaches you what happened that season is very much in the public domain. It was a very visible, difficult time for Honda and McLaren. I think honestly they probably launched it a little too early. They rushed it all, and for good reason. But it was a difficult time. But it certainly teaches you how to manage your stress, how to manage what's going on in sort of particularly difficult circumstances. I remember one time I was pre-season testing and the system wasn't working. And I must have spent 3 days under the car just trying to get it working. It wasn't something to do with me. It wasn't my fault that it wasn't working. But I seem to be the only person there that sort of knew what what was going on or was related to that system. I think I just spent 3 days, sort of 15-hour days under the car, just trying to work out how we can get it working with all of the TV cameras pointed at you, going, why is the McLaren getting out of the garage? Why aren't they doing anything? So it's that was a good experience.
So at that point, you might have wished you were locked in a cupboard doing coding and hadn't decided
exactly,
the car stuff was.
It could have been somewhere nice and
sitting on a beach.
Exactly. Yeah.
Quite so a big deal doing that in the F1 environment, particularly in that era, because I mean, like you say, so 2014 was still, that EV industry is still fairly small at that point. There's not loads of people who know much about batteries. In F1, it was all very new, and you know, there were even fewer people who knew how to build hybrid systems for Formula One cars. So really at the cutting edge of what was going on and what was happening in the sector at that point in time.
I'd like to think, certainly I was very lucky, sort of falling into the PhD, a number of years earlier, and sort of being able to be at that, the start of the growth of an industry, really.
Yeah. And then you spent a bit of time at McLaren and then decided to get a proper job.
Yeah, something like that. So the company I was at, LifePath, they'd been purchased by a group called Maughan. There was an individual who'd purchased LifePath and actually purchased a couple of other companies in a similar sort of space, and they persuaded me to come back and be managing director of essentially what was LifePath. They'd had some investment. They'd built a couple of the projects and wanted me to come back and run that side of the business. As you say, not a huge amount of people with a lot of experience running those sorts of business at that time.
Yeah.
It was an opportunity I couldn't pass up, really.
Yeah. You were going to miss lying on the floor under the back of an F1 car.
Exactly, being shouted at by angry execs.
Yeah.
I never got shouted at. I should say that, but no. It was. And I think the other side is with Formula One. It's great being at the forefront of the development, but equally there's an element of rinse and repeat about it every year. I knew if I stayed there for another year, I'd maybe make the battery system a little bit better. I might take half a kilogram off it or a few hundred grams off it, and they'd be happy with that. But that initial piece of innovation that I'd gone there for was over.
Yeah,
and so it was looking for that next challenge, really, which is what I saw in Maughan.
A lot of people, I mean, it's funny because people don't like the rule changes, but without the rule changes, it's quite heavily regulated Formula One in terms of what you can and can't do, and really the rule changes sort of drive a lot of the innovation. Without them, which I think is why some of the teams push for, they kind of want to have fewer innovations and changes, because actually the more you change, the more risk there is, and
the more it costs.
Yeah, the more cost to push. Yeah,
it's about cost, and you've got the big teams, the Mercedes, the Red Bulls, who can throw money at it and do it, and you've got the smaller teams who are literally just trying to survive. McLaren's probably somewhere in the middle. But all of those changes cost a huge amount of money. You can't, It's
interesting seeing that how that's sort of currently playing out at the moment. There's a bit few sort of unhappy people with the big changes the last year or two. The pendulum swung. So you went. I'd say at the time, I can imagine you're probably thinking, this is going to be great, MD, all fantastic. But could I suggest jumped from the frying pan into the fire a little bit in a kind of startup mania?
It was startup mania. There was, there were three sort of companies in the group, all sort of small companies, all with their own quirks. We as a management team, I'd like to think we did a good job of starting to bring some sense into it, bringing it together and turning, ultimately it's difficult when you buy what are, not all of them to be fair, but I think there were 6 or 7 companies in total that were purchased and put into the group. And probably 2/3 of them had been failing beforehand. So they were companies that had had some good technology, but ultimately hadn't had the turnover to survive and keep themselves going. So they'd been picked up for not a huge amount of money, and the idea being, well, if you put them all together, and make them work, actually there's a better business there.
Yeah.
That's great, but you got to have deep pockets to get over the reason why they didn't make money in the first place.
Yeah.
So we did some really cool projects. We did on the battery side. We did a battery project for a car that beat the Nürburgring lap record. That was good fun.
The EP9 perhaps?
It is, yeah.
You didn't say it, I did.
No,
if anyone's interested in looking that one up, the Neo EP9 is a pretty cool car, which again was very much ahead of its time.
It was a very cool car, and again, really, really interesting project. Using a lot of sort of Formula One technology in it. And then really the problem was funding the turnaround of those groups of businesses. Just became a little bit too difficult. A number of things conspired against us, and even actually the battery side of the business was profitable, and we had some good customers, and we were making good headway, and everything else just wasn't the cash there. And like so many other businesses, if you don't have the cash flow, then there's only so much you can do, and the cash flow sort of ran out, and we had to I have to say one of the hardest days of my life was having to go into the office and tell the employees on payday, sorry, you're not getting a paycheck today, and today's your last day of working. Come in tomorrow, and the administrators will be here. That's the day that'll sit with me for the rest of my life, in terms of looking those people in the eyes and saying, you know what, I'm sorry, there's just nothing more we can do.
Yeah. It's kind of not great that was put onto you and the other guys as well, rather than.
Well, it was a group decision. We all knew where we were, and I still remember we were in a hotel in Luton, sitting down that morning, and we all had to sort of vote and say what we thought was the right thing to do. And unfortunately, at that point, if you haven't got the money to pay your staff, and you can see the other bills that are coming down the line, there's only so much you can do.
Yeah. So picked yourself up and dusted yourself off.
Yeah, something like that. Yeah, well, I was still living in Woking, where I'd been with McLaren Racing at the time, and actually, I took a little bit of time to go. The industry was growing a bit more at that point. Took a little bit of time to sort of look around to see what roles were available. There was a few more options, but the ideal role for me came at McLaren Applied. So this is kind of the technology development part of McLaren Group, as it was then.
Yeah.
They were looking to develop a business in automotive electrification. They had some products that were motorsport orientated. So actually the sort of inverters and the sort of electrification technology that they developed whilst I was at McLaren Formula One, they'd done that part of it.
Yeah.
And they wanted to kind of work out how they got them into the automotive market, and ultimately turned that part of the business from a sort of very, very niche Formula One technology development vehicle into a higher volume, more mainstream automotive supplier.
Yeah.
So they were looking for somebody to come on board who could help out with that. So and it just happened it was 5 miles down the road from where I lived, so it was fairly serendipitous, really.
Quite handy. Did you still have your t-shirt and stuff?
Yeah, something like that. I do still have my McLaren Racing t-shirts. They're good for use them for skiing, actually. It's it's quite funny. The budget for the team kit, I think, went down that year, so they're quite nylon-y, which is quite good when you it doesn't wick the water up so much when you fall over.
Okay, you didn't get the fancy Hugo Boss stuff then.
No, I did the year before, but it's interesting actually. I had Hugo Boss socks. They make you wear Hugo Boss socks, but the other clothes were at that point certainly were communal. So they gave you the shirts and the trousers to wear and everything else, and you could have a Tag watch as well, because we were sponsored by Tag at the time as well.
Yeah,
you could wear that, but it wasn't quite as glamorous as it looks.
Okay, very good. So you're at McLaren Applied, which is now McLaren Applied is still called McLaren Applied, but it's not actually part of the McLaren Group. It still exists today. Very strong in motorsport electronics, and a little quick tab for Transsense's partner in motorsport for supplying torque sensing systems into that field. So McLaren Applied is a great company, very well known all the electronics in Formula One and Formula E and trackside monitoring systems and stuff like that. So great company to be back with. And then and that must have been quite nice, sort of like falling on your feet really after the bit of the ride you
Yeah,
had.
no, it was good, and and fair play to McLaren. Applied Technologies, as we called at the time, they gave. I was given this space to sort of sit and work out what that business should look like. So they wanted to get into automotive electrification, but they didn't really know how to do that. And actually, I can't remember how long it was now, but I was given a good amount of time to actually really understand the technology, take that and look at the market, work out what's going on in the market, go out to the market, get feedback from them, do all the conferences and all of that sort of thing, understand what's going on, and really, really build quite a solid sort of business case and proposition for what that business should be.
Yeah.
There wasn't too much pressure on the right. Okay, you've got 60 days and you have to come back with a business plan, and they were they were reasonably or very, very accommodating for me to finding out what the best business proposition could be, given the technology that they had.
Yeah. Yeah.
So I spent a bit of time working that out, and sort of basic, almost. I guess the stuff, not that I've done an MBA, but the stuff you might learn on an MBA in terms of looking at the market, segmenting it, working out where your technology fit is, all of that sort of pseudo academic stuff that you do in the business to really work out where the best place is. And it turned out, they brought me in actually on the battery side, saying, we think we want to build a business in batteries. Can you help us do that? And they did a bit of battery management system stuff, but no real building of batteries.
Yeah.
And when I looked at where their core competencies were, actually it turned out that the inverter technology was where they really, really excelled, and actually where the business was going and where there was a bit of a gap in the market. So at that point, everybody was looking at batteries. Everybody thought, okay, battery is going to be 1/3 of the bill of materials of future EVs. We want a slice of that. So everybody was throwing money at building businesses around batteries. I was able to say, okay, well, there's this, but actually, we don't have a huge amount of experience doing batteries. Not certainly not in house, and but actually, we do silicon carbide inverters, which for those people who don't know, it's basically the thing that drives the motor. It's the intelligence behind the electric motor. We had really cutting edge technology around those silicon carbide inverters, which if you then read up and understood what was happening in the automotive market around efficiency, and how that impacts the drivability of a vehicle and the quality of a vehicle ultimately, was going to be a really key technology for the automotive industry. So they brought me in to do batteries, and I kind of said, you know what, batteries probably aren't the right place to be. Actually, the silicon carbide inverters is really where what you've already got is going to be best placed for the market.
Because they had, just thinking back at the time, they developed very high power density silicon carbide stuff before silicon carbide was a thing. Because now it's pretty common in cars these days, and I think Tesla was one of the first, but it was before then.
Yes, the stuff that was developed for Formula One. There's a couple of companies kind of looking at it. Wolfspeed, which is a powerhouse now, was literally a tiny little company in the sort of backwaters of America. I remember the guys had to fly out there and were like, what? Why are we flying out to this sort of? They had to take 2 or 3 flights to get to some company called Wolfspeed in America that nobody had ever heard of. And then of course it's bought by Cree, and now it's sort of standalone. It's a powerhouse to some extent of manufacturing in the EV industry. But it was really, really in the early days, and they were sort of working directly with silicon carbide manufacturers to help develop the silicon carbide and then put that into the applications as well. And so Formula One was, talking about that innovation. Formula One was a great place to work out actually how do we make this inverter, this drivetrain more efficient. And there's work from that is going straight into EVs today.
Yeah, and probably actually then that was a fantastic grounding for what you then have ended up doing now. So I guess at some point along that journey, Protean came knocking, and and you made the jump. And
so Yeah, I'd loved being at McLaren Applied. I'd gone through, I think I'd gone through 4 or 5 different CEOs in the time there, and managed to keep things going. And that inverter business unit that I was looking after sort of grew and grew, and that was good. But yeah, Protein came knocking, and I thought, yeah, it's time for a new challenge. Hadn't done so much. So for people who don't know, Protean do in-wheel motors. So we do a motor that gets integrated into the wheel of the vehicle, and then also integrate the power electronics into that area as well.
Yeah.
And I guess one of the things that I learned very quickly when joining Protean is how hard that is to do.
Yeah.
It sounds like, okay, great, you can make a pancake motor and you can put some electronics in there and that's fine. But you're talking about putting really complex electronics and motors in probably the harshest environment within a car, which is mounted within the wheel on the unsprung mass. It's open to the elements. It's literally dunked in freezing water if it's parked up in in a puddle in the snow or anything else. It goes through potholes. It's about as difficult as you can get in automotive. And so that really was what interested me, and was actually there's this really big problem here. There's this technology that's on the cusp of being adopted by mainstream automotive. We're seeing a lot of OEMs wanting to differentiate, and this is a good way of doing that. But there's a real engineering challenge in there as well.
Yeah, and that, because actually, again, sort of looking back, because you've been at Protean few years now, 2 years,
2 years almost now, yeah.
At the time, so Protean's been in the press a little bit recently because of some good OEM business wins, but a couple of years back, you're saying it was on the cusp. It's a company that had very sort of humble beginnings a long time ago, and then hadn't ever quite got there yet. So what's the origin story with Protean?
Yeah, so Protean's about 15, 16 years old. It was born out of another company that had been doing sort of motors, and I think somebody thought, you know what, maybe we can do these motors and put them in the wheels, and that'd be a good idea, and we can develop some IP.
Yeah.
And it was, the early days were, from what I understand, were much more about technology development, proving that this could work, proving this could be a thing, and to some extent building up value in the company through the number of patents they had and the IP and everything else.
Yeah.
Whereas, over the last, I'd say 5 to 8 years, it's had to evolve. It's gone, okay, actually, the technology's there. We kind of know how to do the technology. We can make this work. Now we need to transition into becoming a tier one and actually producing this technology in volume at the right price point for the OEMs.
Yeah.
And so that's been the journey Protean's been on for the sort of more recent past, is transitioning from a technology company. We've got 350 patents or something, which is great, but actually transferring that from a technology company into a company that is capable of manufacturing these products at scale. And again, and that was part of the challenge, saying, okay, but actually this change has been underway, and it's a really good automotive process driven company, and a lot of that hard work has been done. But again, there's still it's at a really interesting time where we're just breaking through into mainstream automotive, and all of the challenges that come with that.
Yeah. So on that, in-wheel motors obviously been something that's been around for a while. That always sort of seems like a really good idea, but then there's always been challenges. So what is it about in-wheel motors that's appealing to OEMs, and what's different now? Like, what's changed?
So it's the benefits are sort of, interestingly, actually, the benefits are less technical and slightly softer than that. So really the benefits come through packaging. So if you can push your drivetrain into the wheels, you save a load of space where your e-axle might otherwise be. But when you start getting into the design of the vehicle, you start to realize how much of an impact that quite simple, okay, we can package it in the wheels concept, how powerful that can be to vehicle design. So if you think about crash, for example, if you've got an e-axle in the front or the rear of the vehicle, you've got an incompressible mass in the vehicle there. So your crash structure has to be in front of that e-axle. But your wheels have to be in line with the e-axle. If we're talking about the front here, so the distance between the front front of the car and the wheels is set by the crash structure and then the dimensions of the axle. If
Right.
you get rid of the axle, you can start to move the wheels further forward. And if you move the wheels further forward, you can start to have more internal passenger space.
Yeah.
So you say, well, actually, we can design a C segment car that feels like a D segment car. It's the same size as a C segment, but because you can push the A and the C pillars further apart, you've got a lot more internal space.
Right. And a wheel on each corner also makes it handle like a go-kart.
Well, either you can make it handle like a go-kart, or you can say, well, what happens if we tune the handling so that it's a C segment car, but it feels like a D segment car, or
Okay.
so you can tune into the torque vectoring. You can say, well, actually, let's have it accelerate with the kind of momentum that a bigger car would have,
Yeah.
and you can start to tune that in. So if you want a car that's actually comparatively small on the outside but feels like a big luxury saloon, you can use the torque vectoring side of things to program that in.
That's interesting. So torque vectoring is a thing. So just for listeners, so basically in a normal electric vehicle, even if you've got a motor electric drive in the front and in the rear, very, very few electric cars have sort of true torque vectoring where they've got a motor driving each wheel. I mean, there are a couple out there. Some of the high-performing Teslas have got two motors on the back, one driving each side. I think Honda NSX has got two motors in the front driving each wheel, but they're mounted inboard in an e-axle, and the ability to independently control the torque that you put onto the wheel starts to give you some quite radical things you can do with the car. Because normally you've got a differential, which differentials are great because they allow cars to go around corners, but they do exactly the opposite to what you want them to do in terms of putting torque on the road. So
exactly.
they put the torque to the wheel that's got the least grip. And everyone if you turn a corner hard, it's always the wheel spins as it's getting lifted off. So going around corners in too fast in car parks and stuff, you get the little chirrup from the tires and all that kind of thing. But if you can actually get rid of the differential and truly control the torque being put to each wheel, that completely just transforms the way you can control the vehicle and actually get a lot of mechanical complexity. So in some cars, things like active differentials, four-wheel steering and stuff that are done to kind of compensate for the normal system, you can get the same kind of benefit as you could with that sort of system, but in wheels and true torque vectoring.
No, exactly, and you're absolutely right on all those points, and that's one of the first things people come to is the torque vectoring. Certainly, the sort of geeky engineers, as it were, think, oh yeah, torque vectoring, that's quite cool. But the reality, interestingly, and that was my first thoughts as well. Interestingly, the reality is, again, it comes more about what you can do with the vehicle. So coming back to we haven't got those e-axles there now. That also means you've got more space in between the wheels to fit your battery pack.
Yeah.
So you can start to fit a larger battery pack into the vehicle. Do you need a bigger battery pack? Maybe not. But you can you have more space available there. If you combine that with the fact, your A pillar's further forward, actually you can reduce the angle on that so that you get aerodynamic benefit.
Yeah.
So efficiency is a massive challenge for EVs. You need to be more and more efficient. Aerodynamics is a big chunk of that. So if you can reduce your coefficient of drag by moving the A pillar forward and reducing that angle of attack to the front, you can reduce the aerodynamics. And then you think, well, actually, with the battery, I've got more space for the battery now. I can have my seats further down, and I can
battery
push footwell exactly in the battery. You can bring the head height down. So again, that increases the efficiency of the vehicle. You get rid of all of the subframes you need to hold these big e-axles in place, and all the bracketry, so you save weight. So from a vehicle point of view, you end up with a lighter vehicle, a more aerodynamic vehicle, a more efficient vehicle. And so the torque vectoring is definitely a part of it, but it's a much smaller part of it than you think of when you first look at it.
So actually, from everything you've said there, because there's a lot of things that I'd not thought about before, it is massive. You're talking about completely rethinking the design of a vehicle.
Exactly, and that's one of the challenges in introducing the technology is you can integrate it into an existing platform. We've done 50 plus different demo vehicles, usually where you've got an existing vehicle and you're trying to integrate the motors into the wheels. But actually the biggest benefits come from having a proper dedicated platform that utilizes in-wheel motors as the primary drive, and that's how you can start to get these step changes in vehicle performance.
So you have to have an OEM that's really committed to the vision and wants to do it and get the most out of it.
I think in order to get the most out of it, you need to be looking at how that integrates with the platform.
Mm.
But of course, that's not going to happen straight away. And I think the early adopters are going to be fitting into existing platforms.
Yeah. And my favorite, you've got these demonstrator vans where you've put the in-wheel motors on the back axle of a front-wheel drive van. So you've got a sort of hybrid through the road system and a four-wheel drive van, which I always think is very, very cool. I'd like to do that on my motorhome at some point, so I don't get stuck.
No, we do. It's quite interesting. It's quite interesting. So yeah, so part of our business, we're Protean are owned by a company called BDO, and I look after some of the technical side of that as well. And they do vehicle conversion, so converting vehicles to essentially hybrid electric vehicles. We call it bimodale, meaning it's got two modes. So it's either diesel or electric. It's technically not a hybrid because we don't typically run them together. But it gives you things like electric only running. But you can have four-wheel drive for getting out of muddy spaces. We can do a sort of four-wheel drive version. We have worked with some camper van companies as well. I can't say too much on that.
If you want a nice demo, give me a call.
Yeah. But but again, the biggest benefit comes from the packaging. If you look at a lot of commercial vehicles that do EV, they have to lose some of the floor. They have to raise the floor up in the back to fit the e-axle. Where again, if you have your drivetrain in the wheels, that you don't lose any of that floor space. You keep the same load space.
Yeah, even when you sort of like the design of a very big commercial vehicle, like a truck or whatever, the floor is never in the back of the truck because they've got a solid axle and they've got all the prop shaft and the drives and everything. The load space is way up. It's sort of shoulder height, which makes trucks hard to load and whatnot. Whereas if you had in wheel, you can have it basically walk-in access to the back of the vehicle and stuff like that. Yeah,
exactly.
Yeah. Very cool. So lots of potential, and now like, as can be seen in the press, some OEMs are picking up on this, and you guys have got programs starting to be known about and talked about, and I'll be careful that I don't say anything I'm not supposed to. So I'll let you talk about that if you want. But what's the thing that's really then making the difference for the OEs? Is it just a differentiation thing of like we've got to try something or is it, have you guys nailed is the cost come down, or what's made the difference in terms of starting to get these big commitments?
I think some of it and none of it, or all of it. I think we're in a really interesting, when we look at the industry and how it's evolved over the last 20 years. I think up until a couple of years ago, it was a really boom time for the EV industry.
Yeah.
Now I'm not. I disagree with a lot of people who are naysayers at the moment. There's a lot of negative stuff out there about EVs and the technology at the moment. Let's be fair. The market share of electric vehicles is still growing worldwide.
Massively.
People like to talk about it declining. What they actually mean is the rate of increase is declining, not that we're still increasing the market share. So you need to be a little bit careful when people are saying, well, the EV industry is failing. It's absolutely not.
Yeah.
But what we are seeing is a lot of investment that's been put in by the OEMs to get to this point, and them saying, okay, we've invested a huge amount of money. Actually, we've got to a point where the technology works.
Yeah.
And I think last month in the UK, 20-something% of new cars sold were EVs. That's not untypical for many places around the world. So the technology is there, it's working, but the OEMs have got to try and recoup a lot of that investment.
Yeah.
So what we're seeing is there's not the same money around for R&D that there was 4, 5, 6, 7, 8 years ago.
Well, the market's been tight as well, hasn't it? In that a lot of the OEs that were making loads of money in China aren't anymore, and also just because interest rates have been so high for such a long time. If you look at sort of sales, it's quite sort of in the detail, but a lot of the OEs made a lot of money in China, but then they made a lot of money on expensive SUVs.
Yep.
with 10% cost of finance. Now the
Yeah.
lease cost for your big SUV is doubled, whatever. So it's hard to sell cars, or has been really hard to sell cars the last couple of years, full stop, let
Yeah.
alone
Yeah.
any.
And
But as
EVs.
you say, people have twisted the numbers. So even though it's been hard to sell cars full stop, the share of sales of EVs and the sales of EVs has been consistently going up in against that headwind. So people who are betting against EVs are really making a bad bet at the moment.
Completely agree. And if you look at it, we're perhaps tracking slightly behind the original 2030, 2035 numbers, but we're not far away. And successive governments may well try and loosen the targets on the OEMs. But actually, if you look at the graph, we're pretty much tracking towards
Yeah.
that anyway, happening naturally. So I think you're absolutely right that you'd be a fool to bet against the EV industry. So don't listen to certain papers or certain politicians. Would be my
The other great
advice.
one, or my current bugbear, electric vehicles depreciate. The depreciation is horrendous. Look at the depreciation on this. You're like, yeah, but like a big German SUV also depreciates horrendously anyway. So,
Yeah.
it's not any different to.
But it's not. But 2 or 3 years ago, EVs weren't depreciating at all.
They were getting more expensive. You
They were getting more
yeah,
expensive.
went the other way.
Partially driven by sort of the availability of spare parts and things like that. But there was the opposite problem in that the opposite problem was because you couldn't get hold of the spare parts, and because people were then buying up second-hand EVs. It was getting more. Insurance was getting expensive.
Yeah,
because the cars themselves weren't cheap enough.
Yeah.
To replace, so the insurance was getting expensive. So there's going to be a certain amount of market settling. My view is ultimately, I think second-hand EVs are going to be quite strong generally. The amount of value in an EV in the battery pack is going to be high compared to any other vehicle.
Yeah.
I think we'll have the opposite problem in that you'll get a vehicle at end of life. The battery packs seem to be lasting longer than the actual vehicle itself, and you'll have more value in the battery than you will in the rest of the steel and aluminium in that vehicle.
It'd be interesting to see. The cars typically, like now, are much better made than they were. We were sort of having a laugh the other day talking about cars we used to have when we were younger, when we was a lad. And basically, when I learned to drive, to keep a car on the road, and when I was thinking, I was like, crikey, that car actually wasn't that old, but I needed to be able to weld because it was going to be full of holes. So you had used to be body work and stuff like that would write a car off because it wasn't economic to repair. Then all of that got so much better, new paints and sort of metal protection systems and aluminium and whatnot. So that's better. So that tends to be emissions related stuff that writes cars off now. And obviously an EV has no emissions related stuff. So then you're into really failure of electronics units, and that will happen. But then you have complex electronics in.
There's more complex electronics
cars.
on a modern diesel or petrol engine than there is on an EV.
Yeah, I was in a garage this week actually, and I was sort of we're doing something. Went into this workshop, and there was a Range Rover up on the ramps, and it was just it had exploded its intestines all over the floor. And it was in the really expensive, not very old Range Rover with a snapped crankshaft, having to have the whole engine replaced, and that was a major bit of surgery, So not a battery pack in sight.
No, exactly. And there's the same old tropes of these. EVs catch fire when, again, the data says they don't, and more petrol and diesel cars catch fire as a percentage of the car park than EVs do. There's when you look at the data, we have to, we're both in the EV industry. We have a slight bias, but if you look at the data, actually, an EV is generally a better vehicle to drive. You'll have the odd person that'll say, "Oh, well, I miss having gears and I like driving gears." Well, yeah, that's kind of because you've got this ridiculous sort of rotating engine that you have to have different gears for, and have to have a clutch and everything else. It's for 99% of the driving, it's a much smoother, much more enjoyable way of driving.
Less NVH, less.
Exactly.
The thing that starts to become a bit of a bother, and I've had this. So my last car was fantastic, and the car I'm driving at the moment, also a fantastic car. EV. Like this week alone, I must have done 700 miles or something.
Mhm.
So, fine in terms of range and all the rest of it. But it's so quiet that you can hear every little rattle. And
Yeah.
the last car had a couple that were really annoying and I just couldn't get rid of. This one,
Right. Okay.
I won't say what it is and who it's made by, but it's a premium car. And it's really annoying little rattles coming from the back. Which you wouldn't be able to hear if it was a combustion engine car, but it's
No.
just, you just notice it. So turn the radio up and, try and turn my rattle detector off and off we
Exactly.
go.
It magically goes away when you turn the radiator on. Turn the radio on.
Yeah,
Yeah.
yeah, definitely. So yeah, it's a good place in the market. So these manufacturers have got the confidence now, and they're going with the Protean technology. Do you see much in the way of competition in the market? So are there lots of companies doing in-wheel systems, or Protean got the?
There's a few. I
Mhm,
think Protein have been doing it as long as anybody. There's another company based out of Slovenia who've been doing it a similar amount of time.
mhm,
Maybe on quite the size that Protein is.
yeah,
There's a new entrant in Germany who's making waves. They've had some interesting backers, but we think they're going to learn quite quickly how difficult it is to do.
yeah,
It's one thing having a good idea, actually turning that into a product that works
yeah,
is quite difficult. But then, I think probably one of the biggest indicators is you're starting to see some of the bigger tier ones getting involved. So there's a
yeah,
couple of bigger tier ones who are investing and or developing some of the technology themselves. Again, difficult to say how serious the programs are with them. We don't
yeah,
have a lot of insight there, but there's definitely more happening, and we're seeing. The other side of it is I think we're seeing a lot of interest in China.
yeah,
And China now really is where a lot of the innovation is happening in EV. It's very easy to write China off as well. It's just a low labor cost economy. They make cheap cars.
yeah.
Absolutely not. If you want a high technology vehicle, China are 10 years ahead of the rest of the world at the moment.
It's
Yes,
interesting.
the cars that have typically come over here haven't been probably the flagship cars. If you go to China and spend some time in the showrooms, it's a completely different world.
Yeah, I was in China a month or so ago,
Mm.
and very very lucky, like great trip, wonderful people that we were with, and we were getting driven around in BYD, like the premium brand of BYD. I can't quite remember what it was
Mhm.
called, but this thing, I got to say, it had interesting styling on the outside,
Yeah.
but on the inside, it was like being in a spaceship.
Mm. Yeah, yeah.
You you just couldn't, you wouldn't sell that car here because we don't tend to get driven around. Like, I mean, obviously in taxis and stuff you do, but
Mm.
in China, that's more of a
Yeah,
thing.
the kind of MPV market out there is
Yeah,
really big, and
huge.
having, that's somewhere where the in-wheel motors has the benefit again, similar to the commercial vehicles.
Yeah,
Actually, you push the drivetrain into the wheels, you can have a flat floor,
yeah,
and that's a big deal because then you can have your seats can go all the way to the back, and whoever's being driven around has a lot of footwell space and everything
yeah.
else.
These were typically four passengers, and you see loads of them on the
Mm.
road there. There's
Mm.
several major OEMs. In fact, there was because there's a lot of people in Europe. Volvo announced they were going to do one of these, and people were like, "What is that?
Yeah,
Why
yeah,
are you
yeah.
doing that car?" But if it's for the Chinese market,
It is.
which is obviously important to them. So it's a big,
Mm.
big deal there. But the tech in the car, there were touchscreens everywhere. There was sort of a ventilated, massaging seats
Yeah,
everywhere. The sort of quality of the materials was fantastic.
yeah.
Had Dan audio, high end stereo inside. It was just, and I mean, say the front of it was interesting from a European point of view, but the Chinese love the
Mm.
way they look as well. So
Yeah, I think as well. The other thing that is interesting about the Chinese market is they put a lot of value on NVH as well,
yeah,
possibly more so than sort of European or American markets. Actually having so again being driven around, but something that is you don't feel the vibrations of an engine through you. It is quiet. You can have a conversation with somebody
yeah,
you're sat next to. When you're doing 70 miles an hour down the motorway. They do put a lot of effort into the NVH and the refinement of the vehicles more generally,
yeah.
which
Very
is which is
smooth.
which is interesting. Yeah.
Yeah, 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 definitely very smooth. I mean, actually, the roads are brilliant as well over there. So
Oh yeah.
in general,
Yeah.
so you're not kind of getting bashed up as much as you would be in. Because it was funny, I was in China, and then a couple of weeks after that, I was in Michigan, and it's sort of
Yeah.
like downtown Detroit and driving those concrete roads full of potholes and stuff all the time. It's a different, very different experience. Yeah, trying not to get flattened by a big pickup truck.
Yeah. And I think that's really where the competition is in when you look at the European and American market is, how do you compete with Chinese vehicles? You can, they're not just cheaper vehicles, they're cheaper and better in many ways. And that's the challenge. And that's an area where Protean can help in terms of, them, bringing it back to the aerodynamics and the interior space and everything else, and making a smaller vehicle feel bigger and being able to charge more of a premium for it, etc., etc. Those are the sorts of conversations we're having with OEMs now. Is how do we compete with a technology or a country that's market is probably ahead of ours.
But as a company, you have had some pretty significant success in China, haven't you? And significant operation over there.
Yeah, so we have our manufacturing facility over there. We have a facility in Tianjin where we make all our motors, and we have an office in Shanghai as well where we do quality, supply chain, and of course engineering. So we are a sort of dual nationality, we're a global company, but predominantly UK and China. They're Protean entities. We work as one company. Work very closely with them, and it definitely helps having that presence in China. You're there and you can be talking to the OEMs. The other side of it, of course, is the supply chain. There are certain key components that you just can't get outside of China, and being in China, having a team that speak the language, understand the culture, makes a big difference in being able to get key components, key technology. It makes a big difference.
Yeah, cool. So, mindful of the time, so it's been fantastic talking to you this afternoon. One thing that we normally just ask is sort of looking ahead to the next year or two. What are you most excited about? That could be something in the industry generally, or something for Protean, or like what are you most excited about coming?
Most excited about? Well, I guess most interested in seeing what happens over the next 12 months or so. We've got a lot of political turmoil happening at the moment.
It's exciting. Yeah,
it's exciting.
But in a good way.
It's definitely impacting how we do our jobs day to day and how the industry is. And I think seeing how that's going to fall out, it can't really carry on as it is. At some point, some sense has to take over, you would hope, but I guess we'll see. I guess the next year or two is going to be quite interesting in that respect. I think from a Protean point of view, you kind of sort of hinted at it earlier. We have an OEM contract that we're delivering. It'll be the world's first production vehicle from a proper OEM that utilizes in-wheel motors. That'll be going into production in the next year or so, and so that's going to be taking up a lot of our headspace, a lot of our effort, and it's a really exciting project. I wish I could talk to you about it, but it's a really exciting project, and we're really enjoying working with the customer. There's a great collaborative. We're working collaboratively with the OEM really well because we are introducing this new technology. They as an OEM, they have their own ways of doing things. But of course, we've got that 15 years experience of, well, this is how you need to do in-wheel motors as well. So, working collaboratively with them to make sure for us, what is a really, really important project, and a really important project for the industry, but also for them, what's a really important Halo project as well. So yeah, really, really looking forward to getting that into production.
You got the production hell to go through.
Well, there is that. Yeah.
Brilliant.
Yeah.
Well, thanks so much, Steve. It's been an absolute pleasure. I've been wanting to do this for a while, and I'm really pleased that we finally got the chance to sit down and do it. So thank you very much.
Well, the pleasure's been all mine. Thank you.